Okay, this topic is about conditional probability and the multiplication rule. Okay, so we have learned earlier about probability. So now conditional probability means that we want to predict what is the probability given a certain situation. So there is a special case where there must be a preset condition. Okay, it must be a preset condition before we will predict what is the conditional, what is the probability for a certain event. Okay, so for definition, a conditional probability is the probability of an event occurring when another event has already occurred. So given earlier, one event has already occurred, and then the following will be another event. So what will be that probability of the event? Okay, the conditional probability of event B occurring given that event A has occurred is denoted by this symbol P bracket B given A. So we say P probability event B occur given event A has already occurred. Okay, or in a short term, we read as probability of B given A. Okay, example. Table show the results of a study in which researchers examine a child IQ and the presence of a specific gene in the child. Find the probability that a child who does not have the gene. Okay, now what would be the probability of a child who does not have the gene? So we look at the column of gene not present. Okay, gene not present. So the total is for category child which does not have the gene is 30. Okay, so 30 gene not present over total. Total means that total of gene present and gene not present, which is 102. So the answer of the probability gene not present in child is 30 over 102. Okay. So answer is 0.294. Okay, next. Child who has a high IQ given that the child has the gene. Okay, child who have a high IQ here. So given earlier is the earlier criteria is child has gene, mean that gene present. Okay, gene present and have high IQ. Okay, have high IQ and gene present. So it's 33. 33 over 33 over 72. Okay. High IQ, normal IQ is a total, and probability child has the gene, meaning that in the gene present here. Okay, so the answer is 33 over 32, which is 0.458. Okay, so next, probability that child does not have the gene given that the child has a normal IQ. Normal IQ, and then does not have a gene, mean that gene not present. Okay, gene not present. Normal IQ here. Okay, gene not present and gene present is 50. Alright, so the answer is 11 over 50. So answer is 0.22. Okay, example 2, a person owns a collection of 30 CDs, of which 5 are country music. 2 CDs are selected at random and with replacement. Maknanya bila CD yang pertama diambil, kemudian untuk nak diletakkan semula di bilangan tu akan ada 30 CD juga, dan untuk pilihan CD yang kedua pun diambil daripada 30 CD tersebut. Find the probability that the second CD is country music given that the first CD is country music. So P, second CD, given first CD is country music. Okay, so makna CD yang kedua adalah country music, di mana kita ketahui CD yang pertama country music. Sebab CD yang pertama kita letakkan balik. So bila kita letakkan balik, dia jadi macam sama macam kita buat pilihan kali pertama, iaitu ada 5 country music out of 30. So jadi probability kita untuk dapat second CD which is country music is, sebab ada 5 option of country music CD, so the answer is 5/30. Okay. So B, this time the selection made is without replacement. Find the probability that the second CD is country music given that the first CD is country music. So yang ni bila CD yang pertama diambil, CD dah tidak letakkan semula. So makna yang tinggal mestilah 29. Dan country music CD yang tinggal selepas pilihan pertama yang diambil tu adalah CD country music, yang tinggal adalah 4. Jadi untuk second event akan jadi 4 out of 29. Sebab first CD yang satu ni dah diambil dan tak diletakkan semula, jadi 4 option yang ada, dan juga dah diambil tak diletakkan semula, jadi out of semua CD akan tinggal 29. So answer is 4/29. Okay, independent and dependent events. In some experiments, one event does not affect the probability of another. Okay, example, roll a die and toss a coin. So ini adalah 2 eksperimen yang tidak mempengaruhi antara satu sama lain. Dia tidak mempengaruhi result. Kalau kita dapatkan number 6 untuk roll a die, dia tidak mempengaruhi untuk dapatkan pilihan head untuk toss a coin. Okay. So the outcome of the roll of the die does not affect the probability of the coin landing on heads. So these 2 events are called independent. Okay. Maknanya dua peristiwa ni tidak saling mempengaruhi keputusan antara satu dengan yang lain. So we can use conditional probabilities to determine whether events are independent. So kita boleh gunakan conditional probabilities to determine whether the events are independent. The 2 events are independent if the occurrence of one of the events does not affect the probability of the occurrence of the other event. So yang macam ini sama macam example yang ni. Okay, 2 event are independent sebab result keduanya tidak saling mempengaruhi. So events that are not independent are independent. So event lain yang selain daripada independent, maknanya keputusan yang untuk eksperimen yang kedua dipengaruhi oleh keputusan daripada eksperimen yang pertama. Ini peristiwa ini disebut sebagai dependent event. Okay, example, now classify whether the events are independent or dependent. First, tossing a coin and getting a head, event A, and then rolling a die and obtaining number 6 for event B. So are these independent? Are these events independent or not dependent? So answer is independent, because tossing a coin and getting a head does not affect the result of rolling a die and obtaining number 6. Okay. Next, selecting a king from a standard deck, event A, not replacing it, and then selecting a queen from the deck, which is event B. So is this dependent or independent event? So answer is dependent event. Okay, because by not replacing it, if we select a queen from deck B, it is depend on select a king from standard deck. Okay. Alright. Number 3, driving over 135 km per hour. Event A, and then getting in a car accident is event B. So is this independent or dependent event? It is dependent. Okay, because getting in a car accident normally is a result from driving over 135 km per hour. So it could be the cause. Okay, next, smoking a pack of cigarettes per day and developing emphysema, which is a chronic lung disease. So this is dependent, because we can know that by having a lung disease, this one is a cause from smoking cigarettes. Okay, next, exercising frequently and having a 4 grade point average. Is this dependent or independent? So this is independent because the result does not affect each other. Okay, normally we have a grade in exam is not affected from, it's not based on the result by exercising frequently. The two events A and B are independent if the formula is correct. The formula is true. Okay. For probability B given A equal probability B, or probability A given B equal probability A. So if this is true, then A and B are independent event. To determine whether A and B are independent, so this is how we check whether event A and B are independent. First, we calculate the probability of event B, B or PA. Second, we calculate the probability of B given A, B given A, or PA given B. Okay. Third, if the values are equal, if PB equal PB given A, so event A and B are independent. Okay, if PB not equal PB given A, or PA not equal PA given B, then A and B are dependent events. Okay, example, a random sample of 400 college students was asked if college athletes should be paid. The following table gives a two-way classification of the response. A student is selected at random. Are the events that the student is athlete and the response is should be paid independent? Okay, now kita nak tengok whether events given in the table here is independent or not independent based on the probability and also conditional probabilities. Okay, now take a look at P, probability student athlete. Okay, probability student athlete is 90. Okay, probability student is athlete is 90 plus 10, which is 100. Okay, 100 over total student 400. So 100 over 400 is probability student athlete is 0.25. Okay, now probability student athlete given paid. Student athlete is 90. Okay, and student athlete is 90, and then paid student athlete and paid. So student athlete and paid 90. Okay, now total is student athlete and non-student athlete is 90 plus 210, which is 300. So therefore, probability student athlete given paid is 90 over 300. Okay, given paid, so we have to look at the column paid. Total of column paid is 300 and student athlete is 90. So 90 over 300 is 0.3. So probability student athlete not equal probability student athlete given paid. So therefore student athlete event is, okay, now so probability student athlete 0.25, probability student athlete given paid is 0.3. Therefore, probability student athlete not equal probability student athlete given paid. So therefore, since they are not equal, both event are dependent. Okay, both events are dependent. Okay, next is the multiplication rule. We use this rule to find the probability of two events occurs in sequence. Kita nak cari dua peristiwa yang berlaku one after another. Okay, one after another meaning that in sequence. The probability that two events A and B will occur in sequence is given by probability A intersect B equal probability A multiplied by probability B given A. If the events A and B are independent, kalau B dengan A ni independent, then the rule can be simplified to probability A intersect B equal PA multiplied by PB. Sebab kalau B dengan A ni independent, probability B given A akan sama dengan probability B. Okay, so this simplified rule can be extended to any number of independent events. So ini kita boleh apply kepada event yang lebih daripada 2, 3 seterusnya. Kalau katakan semua event-event tu independent, so A intersect B, intersect C, intersect D and so on akan sama dengan probability A darab probability B darab probability C darab probability D and so on. So this is multiplication rule. Okay. So to use this rule, so kita ada step yang kita senang untuk kita follow. First, find the probability that the first event occurs. Second, find probability that second event occurs given that the third event has occurred. So ni kalau ada A, B and C. So the third multiply these two probabilities. Okay, example. We may use the tree diagram also to show the events and the probability. So kita boleh juga guna tree diagram untuk show the sequence of event. Okay, yang tu lebih cara dalam bentuk a tree diagram. Okay, example, a coin is tossed and a die is rolled. So yang ni adalah independent. Tossing coin and also rolling a die is an independent event. So find the probability of tossing a head and then rolling a number 6. Okay, tossing a head tu kita akan probability dia adalah 1/2 sebab kita ada dua saja event which is head and tail. So kalau dapat head adalah half, 1/2 or 0.5. Okay, rolling a die kita dapat number 6. Number 6 ni adalah 1 out of 6. Okay. So jadi untuk dapat number 6 rolling dice adalah 1/6. So kita darab untuk dapat dua benda ni in sequence, event ni in sequence, kita akan dapat 1/2 darab dengan 1/6. Okay. So the answer is 0.083. Okay, example, two cards are selected without replacing the first card from a standard deck. Find the probability of selecting a king then selecting a queen. So now without replacing, maknanya bila first event kita keluarkan king, so kita tak letak balik. So card akan untuk cabutan yang kedua tu, card akan kurang 1. So all together card ni adalah 52. Okay, now find probability of selecting a king then selecting a queen. Okay, first event kita select king. So king kita ada how many king? King ada 4. Okay, 4 card. So 4 first event is 4/52. Okay, then select a queen. Second so akan jadi darab lah. 4/52 time so queen untuk yang cabutan yang kedua, queen ada 4. And then card akan kurang 1 sebab without replacing. Okay, so kat akan tinggal 51. So akan jadi 4/52 times 4/51. Okay, so check. Answer should be 0.006. Okay, now number 2. 2 cards are selected from a standard deck with replacement. Kita letak balik. Untuk cabutan pertama kita keluarkan. Okay, kemudian kita letakkan semula. Okay. So find the probability that they are both hearts. Okay, so untuk cabutan pertama yang dapat hearts kita ada berapa? How many? 13 hearts. So heart 13 over untuk cabutan pertama 13/52. So sebab with replacement second time cabutan pun akan ada 52 cards juga. So yang pertama is 10/52. Hearts ada 13 lah. Okay, 13/52 time yang second card heart juga pun akan ada 13/52 juga. So answer 13 times 52 times 13/52. So check answer should be 0.063. Okay, exercise 1. The probability that a salmon swims successfully through a dam is 0.85. Find the probability that 2 salmon swim successfully through the dam. Okay, so first salmon swim successfully 0.85 and second salmon swim successfully also 0.27 also 0.85. So 2 events in sequence and they are independent are 0.85 times 0.85 using multiplication rule. So answer is 0.723. 2 cards are selected from a standard deck without replacement. Now find the probability that they are both hearts. Okay, so now without replacement, so first event, selecting a card from the deck is 13/52 because number of heart cards is 13. So all cards are 52. So first event is 13/52. Okay. So because without replacement of cards, so for the second event, the number of hearts reduced by 1 and the number of cards also reduced by 1. So for the second event, number of hearts become 12 and total cards become 51. So the answer is 13/52 times 12/51. So answer is 0.059. Okay, next. The probability that a particular knee surgery is successful is 0.85. Find the probability that 3 knee surgeries are successful. Okay, first knee surgery successful 0.85, second also 0.85 and third also 0.85. So using multiplication rule, answer is 0.85 times 0.85 times 0.85. Answer is 0.614. Find the probability that none of the 3 knee surgeries are successful. Okay, knee surgery success is 0.85. So knee surgery fail is 1 minus 0.85, which is 0.15. Okay, for knee surgery fail is 0.15, second fail also 0.15, third fail also 0.15. So answer is 0.15 power 3. So answer is 0.003. Okay, last one. Find the probability that at least one of the 3 knee surgeries are successful. Okay, so if at least one success, meaning that opposite of none of the 3 surgery success. So this is the opposite of this one. Okay, since this is the opposite of this one, at least one of 3 knee surgery success is 1 minus none of surgery success. Okay, 1 minus 0.003. Answer is 0.997. Okay, now let's do this exercise 2 and check your answer with the answers given at the back of each statement. Okay, so you have to read carefully and try to calculate what is the possible probability using multiplication rule, and then check your answer with the given answer here. Okay, for exercise 3, classify whether the events are independent or dependent, and then try to explain or give your reason based on the situation of independent or dependent events. Okay, so you need to read through the statement here and identify whether the two events are independent or dependent. Okay, for exercise 4, table show the results of a survey in which 146 families were asked if they own a computer and if they will be taking a summer vacation during the current year. Okay, now find the probability that a randomly selected family is not taking a summer vacation this year. Okay, so this one also, try to figure out or find the probability based on the statement and based on the data provided in the table here. Okay, for exercise 5, okay, so now 16 batteries are tested to see if they last as long as the manufacturer claimed. 4 batteries failed the test, 2 batteries are selected at random without replacement. So this is the opposite probabilities. So we need to calculate the complement probabilities. Which one is the opposite? Which one is like a success? If the success is